Hello world, I'm Gloire Rubambiza. I'm a final year PhD candidate in computer science at Cornell University. My research is in computer systems and networking. In order to better anticipate the societal impacts of our research, I took a social scientific approach to study visions and orientations towards societal impact in everyday systems and networking research practice. In this work, we critically explore how CS researchers envision societal impacts in the process of envisioning, building, and publishing about research systems. What factors shape the forms of societal impact that are considered and claimed for the systems, and to what degree these claims and orientations shape the eventual systems that are built. Our conclusion is that, despite good intentions by computer scientists, technical, institutional, and disciplinary structures gradually rework envisioned impact in direct and subtle ways. This is joint work with Phoebe Sengers, Hakim Weatherspoon, and Jen Liu. HCI has long been concerned with finding ways to address the societal impact of computing systems. A key HCI approach to engage computer scientists in societal impact discussions is values in design, or VID for short. Work in VID has shown how values and societal considerations can be built into computing systems at the earliest stages of design. VID is typically done by engaging technical researchers and social scientists in critical dialogue during infrastructure development. In this vein, addressing societal impact is simply viewed as a matter of raising them to the awareness of computer engineers, with the hope that they can design and implement their systems differently. However, Doe et al. Contend that computer scientists face difficulties addressing the societal impacts of their research innovations. One empirical reason highlighted by Shilton in her VID interventions is that technical researchers face difficulties in the eventual impact of infrastructure because, in their view, they are designed to support a wide variety of domain applications. Similarly, in their work on the logic of domains, Rubambiza et al. Argued that computer scientists consider their primary job to be building generic technologies, with societal impact considerations falling under the purview of domain applications. We are particularly concerned with reflections on societal impact within academic computer systems and networking research. We build on a body of work within HCI and CSCW showcasing that some computer networking researchers do consider societal impacts, running counter to the narrative of limited engagement with societal impact. The question we explore here is how computing researchers envision and build toward intended impacts by critically reflecting on the everyday practice of computer systems and networking researchers. We explored this research question through an approach known as critical technical practice. Critical technical practice, or CTP for short, is an approach that continuously interleaves hands-on system development with critical reflection done by the same people. We use CTP because, unlike prior work, where societal impacts were considered after the fact, CTP allows us to unparalleled access to the reality of day-to-day systems building. Critical technical practice was pioneered by Philip Agri in his attempts to reform AI research. Here, we apply it to networking research. Our application of critical technical practice was augmented as follows. I developed prototypes and reflected on these experiences for 12 months using biweekly diary entries. Neustadt and Sengers highlighted the potential limitations of relying on personal experiences in autobiographical work. Therefore, to help mitigate this, we also included data from a longer-term ethnographic participant observation of our research meetings that ran for 3 years from 2020 to 2022. Using these complementary methods, we addressed 3 specific research questions. First, how do academic networking researchers orient to societal impacts in the process of envisioning, building, and publishing about research systems? Second, what factors shape the kinds, forms, and claims of having societal impact? And third, how and to what extent do these orientations to societal impact shape the systems eventually built? Our work follows a case study of the software-defined farm, or SDF for short. The SDF stemmed from interdisciplinary efforts at our university aimed at the domain problem of feeding a growing world population through data-driven agriculture. Concretely, I lead the design of the SDF and implementation to connect a variety of hardware and software in a plug-and-play fashion to enable farm collection and data processing. In our findings, we're going to trace how we work towards the SDF vision, from envisioning the system to publishing about it. Concretely, we trace how societal impacts are within awareness, fade into the background, or completely get forgotten in the different research stages. We began our work for the SDF with the lofty domain goal, that is, How do we sustainably feed 10 billion people in 2050? Achieving this goal required enrolling collaborators who are domain experts in agriculture and industrial partners who can provide technical support, such as cloud computing credits. Together, we charted technical goals that are more aligned with networking. That is, for instance, it would be good to monitor the conditions under which corn fed to a cow is grown. We can also monitor the cow itself, and then any manure coming from the cow can be sent back to the field. This, in a sense, creates a closed-loop system to achieve the farm of the future. From these technical visions emerged research proposals that got funded by organizations like the National Science Foundation and the US Department of Agriculture. This makes funders another set of stakeholders that we are beholden to. Now, with technical goals and funding in place, we spent months in the technical trenches working around low-level hardware and software intricacies to produce functional SDF prototypes. For instance, it took a whole year for me to replicate a bug where existing cow records were being resent to a database and written over by a farm computer. Now, in the midst of dealing with all these intricacies, societal impact considerations slowly fade into the background. The last set of stakeholders I would like to introduce are peer reviewers within our own discipline. We submitted our SDF paper 5 different times before it was published. In those 5 attempts, we slowly realized that reviewers were only interested in the generalizable networking findings, not the specific domain applications. As a result, we gradually stripped the paper of any societal impact considerations to satisfy the reviewers. Working across the different stages then, we constantly had to realign with the different stakeholders on what we would consider collectively as progress or success. Consider the above reflection from a technical progress meeting in 2023. We had a functional prototype that had been running for 4 years, but the system was not completely automated. For it to function successfully, we still had to manually run post-processing scripts before we could feed the data into machine learning models. On one hand, for reviewers then within our discipline, 4 years of experience aggregating network data from point A to point B is considered success enough to get our paper accepted. On the other hand, for our domain collaborators, whether we use post-processing scripts did not matter as long as the machine learning models produce results. On yet another hand, for our funders and industrial partners, the prospect of fresh data coming in implies that the models may need to be retrained. Now, this is a good starting point for a funding proposal for SDF 2.0 research based on 4 years of success with SDF 1.0. The takeaway here is that at every research stage, we re-narrated what the system can do, and this gradually shapes what ends up being built. We will now analyze the intricate relationship between how we as systems researchers view societal impacts and the technical, institutional, and disciplinary aspects that enable, shape, or constrain our work towards said impacts. What we noticed throughout the findings is that we have to present the system differently as we navigate each stakeholder's needs, including our academic and industrial partners. That is, for example, can the SDF support the application in plant pathology or dairy management, or can we use a particular cloud service? For our systems development, we have to consider, for example, can a 32-bit Raspberry Pi run a Docker container built atop a 64-bit operating system? Or better yet, for our reviewers within our own discipline, in doing this research, we had to think, can we produce generalizable networking findings, insights that are divorced from the domain applications? And to the founders and our domain collaborators, are we making enough progress towards sustainably feeding 10 billion people? We characterize this work across structural themes as seam work. That is, an attempt to produce research products that can be narrated as seamless. This work happens between organizations, within the academic structures and across domains, in the technical trenches of system building, and within our own discipline. One consequence of seam work is that the nature and societal impact of the emerging systems are constantly re-narrated to different audiences, producing what we call simulacra of impact. For instance, we argued to our reviewers that the SDF had been collecting data for 4 years, but keeping it alive required so much maintenance and code revisions that it is debatable whether it is the same system. An important benefit then of using critical technical practice is that it allows us to look beyond the simulacra to disentangle the illusion of seamlessness in infrastructure building. Now, if we take a step back and consider what do these insights about seam work and simulacra of impact reveal about critical technical practice itself? We notice that critical technical practice does not happen in a vacuum. That is, we're still working within context of asymmetric power structures that Max Le Boyron characterizes as compromised agency. In our context, our agency is compromised by self-preserving institutional, technical, and disciplinary constraints. Now, CTP enables us to work within and around these asymmetric power structures. In summary, this analysis has made us aware of two things: the role of institutional and disciplinary structures in shaping societal impact, and the role of simwork and simulacra of impact reworking said impact. Now, what implications then do these insights have for pursuing technical research for societal impact within HCI and systems? We provide 3 concrete implications in the paper, including the need for designing new structural systems for societal impact, using critical technical practice to investigate infrastructure, and supporting what we call trilinguals of the future. I will only focus on the first implication due to limited time, but I highly recommend checking out the paper for further expansion on all 3. A key observation from the analysis is that fundamental research, domain applications, and critical reflections are intricately intertwined. For instance, we cannot build a network system tied to particular societal impact goals without considering how our reviewers in networking will receive the domain applications. Therefore, the most prevalent implication for CHI is the need to design new structural systems for societal impact. In particular, HCI researchers could help systems researchers develop new reviewing mechanisms that are sensitive to domain-dependent research. We highlighted prior work in HCI and CSCW that is welcoming of such domain-inclined work done by networking researchers, and that could be a starting point for such a structural system reorganization. Now, we began this talk with the goal of understanding how computer systems and networking researchers orient to issues of societal impact in their day-to-day work. To do so, we use critical technical practice, which is an approach that continuously interleaves hands-on system development with critical reflection by researchers themselves. Our analysis highlighted structural factors and work across them that we call simwork. One of many consequences of simwork is that it produces what we call shifting simulacra of impact. Based on these findings, we present 3 concrete implications for HCI and systems research to advance domain-driven research. We would like to acknowledge our funding sources, including the U.S. National Science Foundation, the U.S. Department of Agriculture, Microsoft, the Center for Research on Programmable Plant System or CROPS at Cornell, and the Cornell Institute for Digital Agriculture.